Hello Math 7 students, this is Open Up Resources 6th grade review of Unit 3 Lesson 6 Interpreting Rates. This is our third video for this lesson and this is the final video. We will complete the lesson today. To remind you, this whole thing is talking about rates, or what we're going to call a little bit later unit rates. That means we're looking at something per something, and the key thing there is that we are talking about per one. We practiced finding per one of these several different situations. We started with our oatmeal, where we first found the 6 oats per cup of water, and then we reversed it and found the cups of water per 1 cup of oats. And so we kind of got started there with the unit rates. We finished our last lesson here looking at these different situations, different recipes or different situations where we're looking at the per one. And so in our last video, we practiced kind of working backwards, figure out what it's really talking about, and the hint is it's usually per one, knowing that that one goes on the bottom, and then working backwards from there to figure out how we should set up the problem, knowing that that one should be on the bottom. And so to get started here, finishing up this whole set of problems here, Tyler paid $16 for 4 raffle tickets. So color coding again, we've got the $16 for 4 raffle tickets. That's our situation. And the question is asking, what is the price per ticket? Key thing here is it says per ticket. And so at this point, again, remember per ticket means per one ticket. So to finish up and knowing how we're going to end this problem, that means that I want 1 ticket to be on the bottom. And knowing that 1 ticket is going to be on the bottom, that tells us then that the dollar amount is what needs to be on the top. And so now I can go back to the original problem, to the information that's given, and when I set this up, I know that I'm going to set it up so that dollars is on the top and the raffle tickets is on the bottom. So $16 on the top and that 4 tickets on the bottom. And setting up the problem is really the hardest part. The rest of it is so easy because it's just equivalent ratios. And we ask ourselves, how does the 4 change to a 1? The 4 changes to a 1 by dividing by 4, which means I need to do the same thing up here, and that 16 will be divided by 4, and 16 divided by 4, plug it into your calculators. That's 4. So again, we have our abstract answer. It says $4 over 1 ticket, or $4 per ticket. We always want to make sure that we are taking these abstract answers and making them quantitative. That's math practice 2. So again, that means $4 per ticket. And what if we reverse it? Now again, when I'm reading this, I am seeing that the question says, well, how many tickets is that per dollar? And again, per dollar means that that's $1. And that $1 should end up on the bottom when I'm done with this problem. Knowing that I should have a 1 in the bottom and that it's going to be measuring dollars, that tells me that the top of that ratio is where I'm going to put the information about the tickets. And so, setting up the ratio from the beginning, so again, this is the end of the problem, but I start at the end to work backwards. And that tells me that at the beginning of the problem, I'm going to have the dollars on the bottom, so $16 on the bottom, and I'm going to have the tickets on the top, so 4 tickets on the top. And again, setting up the ratio is the hardest part. Now, we ask ourselves that question we've asked so many times, how does this number become a 1? And the answer is always we divide it by itself. So 16 divided by 16 will be 1, and so we will be dividing the 4 by 16 as well. 4 divided by 16, I do want you to keep this as a fraction so we can see that same relationship we saw in our last video. And 4 divided by 16 simplifies to 1/4 of a ticket. If you wanted to, you could write that to be 0.25 or 0 25/100ths of a ticket for that $1. But the beauty of keeping it as a fraction is, again, we can still see that reciprocal relationship. Again, we have 4 and we have 1/4. So again, that connection here is that 1/4 is the reciprocal of 4 and 4 is the reciprocal of 1/4. Just like we saw here, the 5/3 and the 3/5. And just like all the others, we're going to make that answer quantitative and say that would be 1/4 of a ticket per dollar. So think about what that means. That means if you have just $1 and you want to go and buy raffle tickets, you don't have enough money. You'll only be able to buy 1/4 of a ticket. And chances are when you go there and say, I want to buy 1/4 of a ticket, they're not going to let you do that. They're not going to cut up that ticket into 4 pieces and let you buy just a piece of it. But it still does give us some helpful information. You'll see why coming up soon. Moving on to number 4, we are now tying in all of these previous problems here together in this problem number 4. It says for each problem, decide which unit rate from the previous situations you prefer to use. We'll talk about what that means when we look at our first one. Next, solve the problem and show your thinking. So if Lynn wants to make extra cheesecake filling, how much cream cheese will she need to mix with 35 ounces of sugar? That means 4A is going to tie in very nicely up here with 1. Now we did have 2 ratios, right? We had our cream cheese per ounce of sugar, and we had our sugar per ounce of cream cheese. So let's start by writing that original ratio. And again, that original ratio, let me scroll up one more time. That original ratio was 12 ounces of cream cheese and 15 ounces of sugar. So 12 ounces of cream cheese and 15 ounces of sugar. Just going to write it down here so that it's easy for me to see and I won't have to keep scrolling back up. The question is asking how much cream cheese will she need to mix with 35 ounces of sugar. So this is asking a different question than we saw up above. Remember up above it was always for every, per, or for 1, and so we're always looking for the 1. This time it is asking a different question. And it says for 35 ounces of sugar. So let's start by writing down that original ratio, which was 12 ounces of cream cheese. Remember my abbreviations, 12C for cream cheese, 15S for sugar. And what I want you to notice is this. Can we very easily change a 15 into a 35? And the answer is no, we can't easily change that 15 into a 35. I can try and double it and it's not enough. I can try and triple it and it's not enough. So it's not very easy to do that. And so that's where taking that baby step that we've already taken up above and finding that unit rate is really helpful. It's not easy to change a 15 into a 35. It is, however, very easy to change a 15 into a 1. So easy, in fact, that we have already done that. And then it's also very easy to turn a 1 into any other number like the number 35. So we've already answered this question. How does the 15 change to a 1? Well, we divide it by 15, and that's why we already did that here as well with our 12. We divided by 15, and that's where we got our 4/5, or I'm going to go and use a decimal this time just to make it easy. 8/10 of an ounce of cream cheese for every 1 ounce of sugar. So again, now the question is, how does the 1 change to a 35? Well, we multiply by 35. How does the 8 need to change then? We also will be multiplying by 5. So 0.8 or 8/10 multiplied by 35, getting out my calculator here. That gives me 28. So 28 ounces of cream cheese for 35 ounces of sugar. 28 ounces of cream cheese, making this quantitative. Okay, so we did ask the question, but let's pay attention to what it said in the beginning. It says for each problem, decide which unit rate from our previous situations we would prefer to use, and look at which one we did use. We used this one here. We used it where the sugar, which is changing to a 35, was already changed to a 1. So working through this problem, that already kind of sets me up for success, so I don't have to take this little baby step anymore. When I read it in this next one, it says, how many weeks will it take Mai's family to finish 3 gallons of milk? That means I already know that I want the gallons to be the number 3. And so with the gallons being the 3, I know that gallons is going to be on the bottom, and think back to why. Remember how easy it is to change a 1 into a 3? We're going to start with the ratio where it already was a 1, because we can change a 1 into a 3 very easily. It might not be as easy to change a 10 into a 3, but we've already changed that ratio where the 10 already changed to a 1. And now we're just taking this number that we had here and changing it into a 3. So I'm going to remember that. It was 3/5 of a week for 1 gallon. So again, that was the 1 gallon here on the bottom, and it was the 3/5 of a week. So think about how easy this question is to answer. I'm trying to turn that 1, which we already used, we already found that in our previous lesson, we're turning that 1 into a 3. How does the 1 change to a 3? By multiplying by 3. So I'm going to take that 3/5 and I'm also going to multiply that by 3. And 3/5 multiplied by 3 is equal to 9/5 of a week. So again, that's kind of a weird number. We'll go ahead and decimal that one as well. That is going to be 1 8/10 of a week. For every 3 gallons of milk. So let's write that down quantitatively. 1.8 weeks to finish 3 gallons of milk. Okay, before we move on to this next one, again, I want you to make sure that you're making these connections. These 3 problems for part 4, A, B, and C, they're all related to the work that we've already done. We already found the unit rate. We already found it per 1. So I'm still starting with this original information, but I'm taking that shortcut of knowing that I've already found it per 1. So I'm just taking these per 1 situations to help me answer these questions here. The next and final question is, how much would all 1,000 raffle tickets cost? So again, that is 1,000 raffle tickets. That means that somewhere I'm changing the tickets into 1,000. So I'm going to focus on making that change here on the bottom. And knowing that the tickets are going to be on the bottom, that tells me that the dollars are going to be on the top. And why is that helpful? Again, it helps me figure out the specific unit rate to use. I'm looking for the one, and this one I don't have to scroll too far. I'm looking for the one where the tickets are already on the bottom. Because again, I can easily change a 1 into a 1,000. It's not so easy to change a 1/4 into 1,000. It's possible, yes, but it's a lot easier to change a 1 into any number than it is to change this fraction into the 1,000. So I'm going to take this work that we've already done, and that would be the $4 for 1 ticket. And again, we know how to answer this question. How does a 1 change to 1,000? It's so easy. 1 multiplied by 1,000 is 1,000. And so now I know exactly what to do here with the 4. 4 is also multiplied by 1,000. And so that means if I wanted to buy all 1,000 tickets, it will cost $4,000. We're going to write that quantitatively again. $4,000 for all 1,000 tickets. We're taking advantage of that unit rate. We already found it per 1, and then we can change that 1 into any other number. We're going to skip this Are You Ready for More? Let's finish up here with our summary. This time in our summary, we're going to show our work a little bit differently because the summary page has provided tables for us and there's that extra space. The work is still the same, just how we show the work is a little bit different. Suppose a farm lets us pick 2 pounds of blueberries for $5. So again, we can see that information given to us right here in the beginning, 2 blueberries, 2 pounds of blueberries, and $5. And what we can do with that information, I'm going to draw these arrows, and so that should prompt those questions, and we ask, how does a 2 change to a 1? We divide it by 2. That means that I'm going to take this number 5, and I'm also going to divide it by 2. 5 divided by 2 is 5/2. But we also have a 1 here on the table because we want to find the unit rate on the pounds of blueberries per $1 as well. So I say, how does the 5 change to a 1? We know that would be by dividing by 5, which means I also need to take that 2 and divide it by 5. 2 divided by 5 is 2/5. Focus on this again. I want to make that connection. We can see our reciprocal relationships again. 2/5 and 5/2 are reciprocals. So we get 2/5 of a pound of blueberry per dollar. Remember, that means per $1. And we get 5/2 of a dollar, or it will cost 5/2 of a dollar if I buy just 1 pound. The cost per pound and the number of pounds per dollar are 2 unit rates. Okay, 2 unit rates. And there are 2 because we can always reverse it and we get that reciprocal. A unit rate, I'm going to highlight and underline this. A unit rate tells us how much of one quantity for one of the other quantity. In other words, what that means for one of the other quantity, that's what we focused on getting the 1 in the bottom, making that second quantity a 1. So I'm just going to write that down, 1 on the bottom. And why is it so helpful to know the unit rate or the price per 1 or the number of pounds per $1? It's because I can change that 1 into any other number. So what if I wanted to know how much 8 pounds are going to cost? Well, if I start here at the 1, we can say, hey, I know how to change a 1 into an 8. We multiply that by 8, which means this is also going to be multiplied by 8. You can see that here, 5/2 multiplied by 8 is 8 times 5/2. And it works the other way too. How does a 1 change to a 10? We multiply by 10. So I would do the same thing with the pounds. 2/5 times 10 is that 10 times 2/5 there. So which unit rate we're trying to use depends on what kind of question we're being asked. So we're going to practice this in the coming days. But for now, let's finish up with our cool down. Here it says 2 pounds of grapes cost $6. So I see that started in the table. 2 pounds, $6. What if I wanted to know how many pounds I can buy if I have just $1? So we ask that question, how does a 6 change to a 1? We divide by 6. So I'll need to do the same thing here. 2 divided by 6 is, plug it into your calculators, 2 divided by 6, fractions are friends, so 1/3. And then we have another question, well, what about this one? How does that 2 change to that one? We divide by 2. So now that tells me what I need to do here as well. The 6 divided by 2, plug it into your calculators if you need. 6 divided by 2 is 3. So now we've done the work. Now let's explain the meaning. Again, that's making our abstract situation quantitative, math practice 2. We can see that in this situation, it's 1/3 of a pound of grapes. For $1. If all I have is $1, I can still buy 1/3 of a pound of grapes. And the second one, we can see the $3 in this column and the 1 pound in this column. So that would also be $3 per 1 pound of grapes. Notice, just as I mentioned here, that we always want that 1 to be on the bottom so that it's per 1. We also are writing these when we write them quantitatively so that the 1 is at the end for $1 or per 1 pound of grapes. That's it for today. Don't forget to do your cool down on Canvas, and your practice problems are Unit 3, Lesson 6. Remember, this is our 6th grade review, so 6.3.6 practice problems. That's it. We'll see you next time.